Hello, pre-algebra 2 people. Forgot who my audience was there for a second. So this is going to look a little different because this is what I would call a video version so that you can see some of the resources at the same time. So we are just going to do a video of the no calculator portion, and the calculator portion will be on a different video. So let's start off. We are starting off with a 45-45. So what you are going to want to do is on the inside of your triangle, make sure you write down your ratios, x, x rad 2. And we first want to find A if C is 16, which means that is on the x rad 2 side. So we want to find out what is x. So what we're going to do, there's several ways you can go about this. I am going to multiply both sides by rad 2. It's one way to go. So notice I have 16 rad 2, that's fine, but on this side, the rad 2 times rad 2 simplifies to 2, since that's square root of 4 is 2. So I have 2x here equals 16 rad 2, and we do want to simplify that because we just want x, so I can divide by 2. And solving for x gives me 8 rad 2. So what is my x value? It's 8 rad 2. Now we move over to our C, finding C, the hypotenuse, if A is 5 rad 2. So I'm given that the x value is 5 rad 2, and what I'm looking for is x rad 2. Well, that's like I've multiplied both sides again by 5 rad 2. This was the x, and I still have to multiply by rad 2. So once again, that becomes 2. So the side that has the x rad 2 becomes 10. All right, so that's your 45-45. Next, we are moving on to your 30, 60, 90. So we want to find, let's actually first put our ratios on the inside. So opposite the 30 is the x, opposite the 90 is 2x, opposite the 60 degrees is x rad 3, 2x being the longest side, which is your hypotenuse. So I want to find D, I want to find the x rad 3 side, given that F, which is the 2x side, is 10. So I let 2x equal 10. That tells me that x is going to be 5, and I can then just substitute. So x rad 3 will be 5 rad 3. Now we want to find F if D, so I gave you that D is x rad 3. So D is our x rad 3 side, which is 15 rad 3. That tells me when you compare these two that x is going to be 15. Well, F is the 2x side, so multiplying both sides by 2 gives me F is going to be 30. All right. Now, on the first practice exam, you did have an integer on the side that had a D. So just make sure you know how to do that. It's the same process as we did in number 2. Okay. Now let's move on to the unit circle, which you will have even on the no calculator portion, and go through how to do this. So the first thing you want to remember when you get your test, it's not a bad idea to write down x equals the cosine of theta, y equals the sine of theta, and remember tangent equals sine over cosine, or y over x. And everything else is a reciprocal. Okay, so cosine of 225, we go through around the circle. Here is 225 degrees. Cosine is going to be the x value, so that is a negative rad 2 over 2. Then we have secant of pi over 2. Well, pi over 2 is right here, and secant is going to be the reciprocal of cosine. So the reciprocal of 0 is 1 over 0, which is a big fat no. So that's going to be undefined. You cannot divide by 0. Tangent of negative 60. So the negative means you have to come back 60 degrees, and that is going to put us here, the equivalent of 300 degrees. All right, so tangent, remember, is sine over cosine, the y value over the x value. But as a shortcut, you can ignore the denominators. They're going to cancel. So, and don't lose lose the negative. So it'll be a negative rad 3 over 1, and there's nothing to simplify there. So our answer is just negative rad 3. Then we go to cosecant of pi over 4. Pi over 4 is right here. That's the same as 45 degrees. Cosecant is the reciprocal of your sine, which is the y value, although both x and y are the same there. So the reciprocal of that would be 2 over rad 2. To rationalize that, we're multiplying by rad 2 over 2, which is the same thing as 1. Remember, this now is going to simplify to 2. My 2's will cancel, and I'm left with just rad 2. So there is another shortcut, but that's, I think, for right now, that's probably the best way to go, okay? Cotangent, 120. So cotangent is the reciprocal of tan, so this will be your x over your y. So let's find 120 degrees. And again, we're going to take the reciprocal of the x over the y. We can ignore the denominator. So that's going to be negative 1 over rad 3, which we have to rationalize. And so that's going to give me a negative rad 3 over 3. And we're going to keep going around the circle here. Sine a negative 5 pi over 6. So realize pi over 6 is the same thing as 30 degrees. 5 times 30 is 150. So basically you're going a negative 150 degrees, which would put you right here. It's 30 degrees away from 180 because you're coming backwards, okay? So negative 150, sine is the y value, so that's going to be a negative 1/2. Now we're up to cotangent of 180. So here's 180. Cotangent is again x over y, negative 1 over 0, which we know is not allowed, so that's undefined. And then we have sine of 450 degrees. Well, this, if I subtract 360, because that's going around the circle more than once, puts me at the equivalent of 90 degrees. That's why we learned how to do the coterminal angles. So I went around 360, and I keep going, and I stop at 90. Sine is now the y value, which at 90 degrees is 1. All right? Hope that helped. So now we have our identities, and if you looked at the answer key, I did do these two different ways because I want to remind you the only identity I'm giving you in terms of Pythagorean identities is cosine squared plus sine squared equals 1. If you need a different Pythagorean identity, you have to derive it the way we did. So if I divided everything by cosine squared, then you would get 1 plus, because cosine squared over cosine squared, plus sine squared over cosine squared would be tangent squared, equals 1 over cosine, which is secant squared. If I divided everything by sine squared, I would have cosine squared over sine squared, which is cotangent squared, plus 1 equals 1 over sine squared, which is cosecant squared. Now, if you want to derive those for yourself, then that's great. But you can also avoid them. So I'll show you how to do these two different ways, and then you decide. So on number 13, the first thing I see is I have a common factor of cosine squared. So I'm going to factor that out, cosine squared x. That leaves me with a placeholder, so it's as if I divided both terms by cosine. So then I have 1 plus tangent squared, and that's equivalent to cosine squared x times, using the identity 1 plus tangent squared equals secant squared, I can put in here secant squared x. And then we can use our reciprocal property, which you should know. 1 over cosine squared is the same thing as secant squared, and those basically cancel each other out to give us 1. Now, let's say you don't know how to derive that other identity, and you're not sure what to do. Well, you can then start from the beginning, turn everything into cosine squared and sine squared. This is how that would work. I'd start off with cosine squared x plus, we know that tangent is sine squared over cosine squared, times, then we still have a cosine squared x over 1. So I haven't factored anything out, I've just converted everything into sine and cosine. Notice that this will cancel, so I'm left with cosine squared x plus sine squared x, and that is the identity that I'll be giving you, so we know that that equals 1. They're both totally valid, and you get to the same spot. All right, on number 14, again, I can also do this 2 different ways, depending on your comfort level. The first step is probably going to stay. Now, this identity here, I will be giving you. So let's just start off with writing cotangent squared theta plus secant theta times, and I'm going to rewrite sine pi over 2, that's a co-property, so cosine theta. All right, so then we're going to go cotangent squared theta plus, I know that secant is 1 over cosine times my cosine theta, and these will cancel, leaving me with cotangent squared theta plus 1, and now you can pull out your, if you're comfortable with that, you can pull out cotangent squared theta plus 1 is the same thing as cosecant squared theta. So that is one way to go, and again, if you're not comfortable with those Pythagorean, let's do the other method, which is to turn everything into sine and cosine. So we start off from the very beginning, cotangent squared, which is, cotangent squared is cosine squared over sine squared, because it's the reciprocal of tan, plus secant will be 1 over cosine theta, times, now here you will need the identity, but you're given it, cosine theta. And as before, notice these will cancel. So I have cosine squared theta over sine squared theta plus 1. And you're thinking, well, how does that help me? Well, I can rewrite 1 as a common denominator. I'm going to write it as sine squared theta over sine squared theta, because that's the same thing as 1. So now I have this common denominator. So if I write the fraction as one fraction, on top I have cosine squared theta plus sine squared theta all over the common denominator sine squared theta. Well, this numerator is an identity I'm going to give you. So that's 1 on top over sine squared, and you know the reciprocal property that that's the same thing as cosecant squared. So notice it took a little bit longer, and you did have to do the common denominator, but you didn't have to kind of derive any other identities, okay?